Good afternoon, Precal type people. Hope you're having a fantastic day today. Today we're going to be learning about exponential functions. An exponential function is a function that grows exponentially or decays exponentially, but it's exponential. Okay, so to get an idea of what's happening here, the graph of y equals b to the x, b is greater than 1. To get an idea of what's happening here, let's plug in some values, like -1, 0, 1, 2, 3. And I'm going to use the example over on this graph, 2 to the x. Well, what's 2 to the -1? Well, it's 1/2, right? We know that from yesterday. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. So let's graph some points on what's happening here, and you can kind of see that what it looks like is going on 1 to 2, 2 to 4, 3 to 8. It's getting progressively bigger and bigger and bigger with each go. So really quickly here, domain is obviously all real numbers. You can plug any number you want in for x, it's fine. Range is from 0 to infinity, not touching either one. You do have a y-asymptote of y equals 0. There's no symmetry anywhere here. It's not a y-axis reflection or an origin reflection. It is 1 to 1. There's 1x for every y. It's decreasing for all real numbers, and it's never increasing for all real numbers, never decreasing. So, a couple of things here. It's going to be pretty quick. I'm going to try and make it quicker. These tend to go on and on and on forever. But I do want you to just kind of see what's going on here. Up here, notice I had a 2 for my base, and it exponentially grew. Down here, I have a 1/2 for my base. So let's see what happens when you have a fraction for your base instead. Now, to do this, I know what I'm going to need in advance, so I'm going to make a point. I'm not picking these numbers at random. I am specifically picking them because they will give me nice results. 0 and 1. If I plug a -3 in here, I get 1 over 2, -3, -3. That's 2 to the third power, which is 8, right? You put a -2 in there, 1/2 to the -2 is 4. -1 to the -2 is 2. 0, or 1/2 to the 0 is 0. 1/2 to the 1 is obviously 1/2. It's actually the reverse of what's happening here. -3, 8. -2, 4. -1, 2. 0, 1. I wrote 0. Goodness gracious, it's 1. Anything to the power of 0 is 1. 1, 1/2. And it's the reverse of what happened below. We call this an exponentially decreasing function. And it's not because it's a negative value. It's because you're getting less by a power of 1/2 every time. You know, if you take half of everything you own and then cut that in half, and then cut that in half, and then cut that in half, that's basically what you're getting here. From 8 to 4 to 2 to 1 to 1/2 to 1/4, on and on and on and on. So just a few quick answers here. Domain, again, is all real numbers. Range is from 0 to infinity. Asymptote at y equals 0. No symmetry. Still 1 to 1. Never increasing, but always decreasing. That's the difference here. So the key to increasing, decreasing is the base. If the base is a larger number, it's going to be increasing. If it's a smaller number, like 1/2, it's going to be decreasing. But let's actually give some actual values to what I mean by larger and smaller. Exponential functions are b to the x. B has to be bigger than 0. It just has to be. Because if it's less than 0, if it's a negative number, then it'd be irrational. It would no longer be exponential. It'd be a rational function because you'd have to flip it to the bottom. So, but it can't be 1. B cannot be 1, right? You can't have just 1 to some power because 1 to any power is 1. So B can't be 1. So what you've got is you've got B somewhere between 0 and 1 is okay. Between 1 and infinity is okay. But 1 itself is a no-go. Now here's what happens when it's greater than 1. Greater than 1 is increasing, kind of like this guy right here. Between 0 and 1, meaning a fraction, it's decreasing. Because it's getting cut into a fraction every time. A fraction of a fraction of a fraction would be decreasing the whole time. And all exponentials share a one point that they have in common. One point that they have in common. They will always, always, always go through the point 0, 1. Because anything to the power of 0 is 1. So every single function will go through the point 0, 1. Now obviously we're going to transform them and transpose them and all that jazz. We'll get to that later. But then 1, and there's one other point that they share. It's not the same, but they do share the value 1, b as well. In other words, if you plug a 1 in for x, you're going to get whatever b is. 1, b. Now, I am not going to be that picky with these. So the majority of what I'm going to tell you to do is going to be calculator based. And this is a big change for me. At first I drilled and I drilled and I drilled, and I'm just not feeling it. Not that I think it's not important, but on the contrary, it's not that much used anymore. So we're going to do this here pretty quick. First off, 5 to the x plus 2. I'm just going to go through, we're just going to power through some transformations here. I'm not going to spend a whole lot of time on them, but you know it's up 1. You did have an asymptote at 0, or it's up 2 rather. So you're going to have an asymptote right here, right, at 2. It's never going to cross that. And if you go from here, up 1, and then over to 1, and if you plug in a 1 into this, plug in the number 1, you get 5 to the 1 plus 2, which is 7. And there's your function. So I'm not going to spend a whole heck of a lot of terrible amount of time on graphing. This is mainly meant to be an introduction. Exponential functions are fantastic things to do and to come up with, but I'm mainly concerned more about you just knowing how to graph them, and for that you can use your calculator, any kind of graphing utility. The fallback to that is make an XY chart. So for number 4, if you wanted to, make an XY chart and call it a day. You know, here's what I would do for an XY chart. X, y. Pick some x's that you like. 0, 1, 2, 3. Plug in a 0 up here. 2, 0 plus 1 is 1. So 2 to the 1 is 2, minus 3 is -1. All right. Plug in a 1. 1 plus 1 is 2. 2 squared is 4, minus 3 is 1. Plug in a 2. 2 cubed is 8, minus 3 is 5. Plug in a 3. 2 to the 4th is, 16, minus 3 is off of our graph, so that's irrelevant. 0, -1. 1, 1. Oops, 1, 1 here. 2, 5. And 3 is off our graph. So the question here is, where'd your asymptote go? And it's down 3. So it's going to come like this. So I'm actually not going to do any of this. It's not something I need to stress that much over. It's not something you need to stress that much over. So I'm not going to stress you that much over. Okay, so let's use our graphing utilities and let's have a time. Exponential. Is this thing still recording? Exponential.